Hey, welcome back to ClearSpot. What if I told you that inverters are especially susceptible to failures that can cause significant energy losses, and that a 50-megawatt solar farm in Rajasthan improved uptime by 12% in a single year through smart monitoring, translating to 4.2 million rupees in additional energy generation? What if I told you that machine learning algorithms can now predict and diagnose inverter faults with unprecedented accuracy, allowing operators to optimize resource allocation by dispatching maintenance crews only when necessary? Today, we're diving deep into the critical world of solar inverter monitoring, the technology that stands between your solar investment and catastrophic performance losses. Over the next 20 minutes, I'm going to take you through a comprehensive journey exploring how AI-driven maintenance led to a 27% increase in energy yield at the University of California solar farm, examine real-world case studies where smart monitoring systems detected micro cracks and potential hotspots before they could impact performance, resulting in a 15% reduction in downtime, and reveal the cutting-edge techniques that are enabling operators to predict inverter failures before they occur. This isn't just about watching numbers on a dashboard. This is about transforming your solar inverter from a potential point of failure into an intelligent, self-monitoring powerhouse that ensures peak performance for decades to come. Your solar inverter is far more than just a power converter. It's the intelligent brain that orchestrates your entire solar energy system. The solar inverter is a key component of your solar power system, converting direct current from the solar panels into alternating current for use in your home. But here's what most people don't realize. Most modern inverters come with built-in monitoring features that can provide unprecedented insights into your system's health and performance. Modern inverters feature LCD displays that provide real-time data on energy production and system status. Some inverters offer web portals where you can log in to access detailed performance metrics and historical data. But the real revolution is happening with manufacturers who often provide mobile apps that allow for convenient monitoring and management of your solar system from anywhere. Here's the shocking reality that most solar owners never consider. Inverters represent the most vulnerable component in your solar system. Inverters are especially susceptible to failures that can cause significant energy losses. Unlike solar panels that can last 25 to 30 years with minimal degradation, inverters typically need replacement after 10 to 15 years, making their health monitoring absolutely critical for long-term system performance. Machine learning algorithms are being deployed to analyze inverter error logs and operational data, enabling the prediction and diagnosis of faults. This capability represents a fundamental shift from reactive maintenance, fixing problems after they occur, to predictive maintenance that prevents problems before they impact your energy production. The transformation in inverter monitoring technology is nothing short of revolutionary. Researchers at the University of Lisbon developed a machine learning algorithm that monitors inverter subsystems and sends alerts when anomalies arise. By analyzing data and comparing variables against historical benchmarks, the algorithm can identify faults such as grid overvoltage, undervoltage, and overfrequency. Tests on ground-mounted PV systems show this approach effectively predicts and classifies inverter failures, highlighting its potential to boost the reliability and efficiency of solar projects. This level of predictive capability means that inverter monitoring has evolved from simple status checking to sophisticated health assessment that can prevent expensive failures before they occur. Let me show you some verified data that demonstrates the incredible impact of advanced inverter monitoring. A notable case study from the University of California solar farm showed a 27% increase in energy yield after implementing AI-driven predictive maintenance protocols. But here's what makes this data so compelling. The system's smart sensors detected micro cracks and potential hotspots before they could impact performance, resulting in a 15% reduction in downtime. This wasn't just about monitoring inverter status lights or checking basic performance metrics. The system used machine learning algorithms that create baseline performance benchmarks for each panel and inverter, continuously checking for deviations that could indicate potential issues. The algorithms track key metrics like temperature changes, irradiance levels, and power output, distinguishing between temporary dips caused by weather and actual equipment malfunctions. The success extends beyond academic installations to real commercial applications. A large-scale commercial installation in Arizona achieved a 23% boost in power output by combining dynamic load management with real-time weather data integration. The implementation included automated cleaning schedules and dynamic load management that added an extra 2.4 kilowatt-hours per panel in daily energy production. What's particularly impressive about this case study is how the monitoring system continuously improved as it processed more data, becoming better at predicting panel degradation, optimizing cleaning schedules, and spotting hardware issues before they escalated. This demonstrates the learning capability of modern AI-powered monitoring systems. Perhaps the most compelling case study comes from utility-scale operations. A 50-megawatt solar farm in Rajasthan faced performance dips due to unpredictable inverter downtimes. The plant integrated a smart monitoring system powered by IoT and SCADA solutions, which provided real-time data insights on voltage fluctuations, alerts for anomalies before they escalated into major faults, and predictive maintenance schedules that minimized unplanned outages. The results were extraordinary. The plant improved uptime by 12% in a single year, translating to an ROI increase of 4.2 million rupees in additional energy generation. This case study demonstrates how inverter monitoring at scale can deliver measurable financial returns that justify the technology investment. The broader industry data supports these individual success stories. Smart component monitoring systems have increased detection speed and increased the efficiency rate per supervisory technician by up to 36% compared with the previous efficiency rate. Maintenance costs can drop by 25 to 35%, with 70% fewer breakdowns. Facilities report up to 25% increased productivity and 20 to 25% extended equipment lifespan. These aren't marginal improvements. These are transformational changes that fundamentally alter the economics of solar energy systems. Modern inverter monitoring has evolved far beyond simple status indicators to sophisticated AI-powered diagnostic systems. The Infosys Solar Inverter Predictive Maintenance application is built on advanced patented artificial intelligence and machine learning techniques. This application helps reduce the downtime of solar inverters by providing user-friendly visualizations on inverter-wise, field station-wise, and site-wise information on alerts and outliers, as well as on energy losses. The application utilizes detailed analytics to predict different types of failures and help the ground team take proactive measures, which results in optimal solar plant performance. Unlike traditional monitoring systems that simply track thresholds, AI doesn't just track thresholds. It learns from historical patterns, real-time signals, and even environmental conditions to recognize subtle signs of underperformance. The sophistication of modern monitoring systems is truly remarkable. Convolutional neural networks, or CNNs, are, really powerful for analyzing image data, especially thermal and RGB images collected via drones or fixed cameras. When applied to inverter monitoring, these systems can detect cell-level faults such as cracks or delamination, shading from vegetation or nearby objects, and also overheating modules and junction boxes. Long short-term memory networks, or LSTMs, constitute a kind of recurrent neural network that excels in handling time series data. They learn from sequences of voltage, current, temperature, and irradiance measurements to predict imminent inverter failures, gradual panel degradation, and irregular power output trends. By combining CNNs and LSTMs, developers can build highly accurate models that account for both real-time and historical performance data. Professional inverter monitoring systems track multiple critical parameters simultaneously. The best monitoring systems track performance at the string or even panel level, allowing operators to identify specific underperforming components quickly. Advanced systems use machine learning algorithms to distinguish between performance variations caused by weather and those indicating equipment problems. Multiple diagnostic methods and accurate fault identification help streamline troubleshooting with reduced time. Real-time data ensures refined and all-inclusive control of the power plant, covering the entire system, subarrays, equipment, and modules, leading to enhanced management efficiency. Faulty modules are highlighted in red for quick identification, and the Alert Center, simplified and easy to use, always urges prompt repair for the situation with a higher priority level. One of the most powerful diagnostic tools in modern inverter monitoring is thermal imaging analysis. AI algorithms identify and localize hotspots on solar panels, which indicate areas of excessive heat that can reduce efficiency and potentially lead to damage if left unchecked. This technology can detect overheating modules and junction boxes that would be impossible to identify through traditional monitoring methods. The coefficient of variation analysis helps locate abnormal inverters and strings within seconds, reducing the inspection scope and saving time and effort. This rapid diagnostic capability enables operators to achieve a higher performance ratio with full link diagnosis, enabling real-time control of power grid status by detecting equipment faults, analyzing operations, and collecting loss data. Modern inverter monitoring platforms provide, honestly, unprecedented real-time visibility into system performance. Traxo Solar is a cloud-based energy management IoT platform designed to track your solar PV system's performance, identify anomalies, and provide immediate support. The platform monitors performance remotely, spots or predicts failures, and offers proactive maintenance of solar PV assets, giving operators full control over your system without actually being present there. Real-time data ensures refined and all-inclusive control of the power plant, covering the entire system, subarrays, equipment, and modules. This comprehensive monitoring approach enables operators to track your solar performance in real time with systems that are smart, reliable, and built for maximum energy optimization. The sophistication of modern alert systems goes, well, far beyond simple fault notifications. Alerts and notifications are set up to notify you of any performance anomalies or maintenance reminders, ensuring timely intervention if issues arise. The Alert Center, simplified and easy to use, always urges prompt repair for the situation with a higher priority level. Traxo Solar provides up to 40% reduction in manual operational cost through real-time remote monitoring, anomaly detection, and data analysis of all your solar PV assets. The system delivers up to 15% savings on generation loss, with comparative analysis and pattern comparison for underperforming assets. This intelligent analysis capability enables operators to prioritize maintenance activities based on actual impact on energy production. Advanced monitoring systems enable, sophisticated predictive maintenance strategies. AI-driven monitoring helps detect performance drops early, reducing downtime and prolonging the lifespan of solar equipment. According to a recent study, 77% of companies plan to transition to predictive maintenance in the near future, with AI seen as the key enabler of this evolution. The SolarLog device monitors the photovoltaic system and detects faults, such as the failure of an inverter, before they become a permanent problem. For a complete overview, the status and error codes of the individual inverter manufacturers are permanently recorded and saved in the event log. This comprehensive fault tracking enables operators to recognize whether the photovoltaic system is working trouble-free and efficiently by comparing the power of the inverters with each other. Modern monitoring platforms enable comprehensive remote diagnostics that can resolve many issues without site visits. With multi-tracker inverters, the SolarLog can detect deviations down to maximum power point tracker level. This granular monitoring capability allows operators to identify specific underperforming components quickly and optimize their service routes, prioritizing the most critical issues. Multiple diagnostic methods and accurate fault identification help streamline troubleshooting, reducing time spent on maintenance. The systems provide real-time control of power grid status by detecting equipment faults, analyzing operations, and collecting lost data. This enables operators to reduce the inspection scope and save time and effort through coefficient of variation analysis, which helps locate abnormal inverters and strings within seconds. Modern inverter monitoring systems are evolving beyond standalone monitoring to become integral components of smart grid infrastructure. Modern inverters offer advanced monitoring capabilities through apps or cloud platforms. Real-time performance tracking can boost system efficiency. This integration enables inverters to participate actively in grid stability and demand response programs. Smart inverters optimize the conversion of direct current to alternating current electricity, improving the overall efficiency of the solar energy system. They can also communicate with other smart devices to balance energy production and consumption. This bi-directional communication capability transforms inverters from passive power converters into active grid management tools. Advanced monitoring platforms integrate inverter data with broader energy management systems. Home energy management systems like Sense or SMAPI allow homeowners to track the performance of their solar panels, monitor energy storage levels, and control the distribution of energy throughout the home. This integration provides real-time insights that enable homeowners to optimize their energy usage patterns. The system utilizes voltage, current, and light-dependent resistor sensors to monitor key panel parameters in real time. This data is transmitted to a cloud platform for storage and analysis. Users can access this data through a mobile app, enabling remote tracking of energy generation, promoting proactive maintenance, enhancing efficiency, and contributing to a sustainable energy future. Sophisticated monitoring systems enable comprehensive performance benchmarking across different conditions and time periods. Comparative analysis allows you to compare performance data over different periods to identify trends, optimize system settings, and address any discrepancies. Weather integration adds another layer of intelligence to monitoring systems. By correlating performance data with local weather conditions, these systems can distinguish between expected performance variations and actual equipment problems. SolarO&M Monitor helps you accurately assess solar project performance in near real time. Using third-party satellite-derived irradiation data promotes transparency and independent validation of performance reporting. With gap and error-free PV output data, you can determine whether any potential performance issue can be attributed to technical factors, rather than weather variability or environmental conditions. For operators managing multiple installations, advanced monitoring platforms provide fleet-wide visibility and management capabilities. SolarO&M Monitor provides consistent and accurate performance data for any location and type of project. By using unified inputs across the whole PV portfolio, you can compare projects efficiently and accurately based on standardized metrics. Critical software built a central control center which was capable of monitoring hundreds of solar farms simultaneously and measuring hundreds of megawatts of power across these sites. This generated insightful business data for Voltalia, allowing them to generate meaningful business, data-based objectives in real time. The system provided real-time data in detecting faults and formulating KPIs while delivering cost benefits of efficient and bespoke energy management. The economic benefits of comprehensive inverter monitoring extend far beyond simple operational efficiency. Maintenance costs can drop by 25 to 35% with 70% fewer breakdowns. Facilities report up to 25% increased productivity and 20 to 25% extended equipment lifespan. When these improvements are applied to inverter monitoring specifically, the financial impact becomes transformational. Traxo Solar provides up to 40% reduction in manual operational cost through real-time remote monitoring, anomaly detection, and data analysis. The system delivers up to 15% savings on generation loss with comparative analysis and pattern comparison for underperforming assets. These savings compound over the life of the system, creating substantial long-term value. The most significant economic benefit of inverter monitoring is, honestly, preventing catastrophic failures that can shut down entire systems. For example, a 50-megawatt solar farm in Rajasthan improved uptime by 12% in a single year, which translated to a return on investment increase of about 4.2 million rupees in additional energy generation. This really demonstrates how preventing even small amounts of downtime can generate enormous financial returns. Smart component monitoring systems have increased detection speed and boosted the efficiency rate per supervisory technician by up to 36% compared with the previous efficiency rate. This improvement in operational efficiency translates directly to reduced labor costs and faster problem resolution, minimizing the financial impact of equipment failures. Advanced monitoring, enables optimization of maintenance strategies that deliver significant cost savings. According to a recent study, 77% of companies plan to transition to predictive maintenance in the near future, with artificial intelligence seen as the key enabler of this evolution. This transition from reactive to predictive maintenance represents a fundamental shift in operational economics. Machine learning algorithms are now being deployed to analyze inverter error logs and operational data, which enables the prediction and diagnosis of faults. This capability allows operators to optimize resource allocation by dispatching maintenance crews only when necessary. This targeted approach really minimizes labor costs and reduces downtime, while ensuring that maintenance resources are focused on the highest impact activities. Modern inverter monitoring systems provide future-proofing capabilities that help protect long-term investments. The widespread adoption of AI-powered solutions is, honestly, poised to enhance solar energy's reliability, ensuring that installations continue to produce clean power. This reliability enhancement becomes increasingly valuable as solar installations age and face more complex maintenance challenges. Artificial intelligence has improved energy output by 25 to 35% and reduced downtime by 70% in some solar installations. These improvements actually compound over time, creating increasing value as systems mature and face more challenging operating conditions. The monitoring systems themselves continuously improve as they process more data, becoming better at predicting panel degradation, optimizing cleaning schedules, and spotting hardware issues before they escalate. So, solar inverter monitoring has, really evolved from just basic status checking to these sophisticated AI-powered health management systems that can actually predict and prevent equipment failures before they even happen. Machine learning algorithms are now able to analyze inverter error logs and operational data, which means they can predict and diagnose faults with, honestly, unprecedented accuracy and reliability. The evidence is, pretty overwhelming. There's a 27% increase in energy yield through AI-driven predictive maintenance, a 70% reduction in breakdowns, a 12% improvement in uptime that translates to about 4.2 million rupees in additional energy generation, and a 40% reduction in manual operational costs. These benefits apply whether you're managing a residential rooftop system or, a huge utility-scale solar farm. Whether you're a homeowner looking to protect your solar investment, a commercial facility manager aiming to optimize energy costs, or a utility operator managing massive solar portfolios, advanced inverter monitoring technology really does offer transformative benefits that honestly justify immediate implementation. In fact, 77% of companies plan to transition to predictive maintenance in the near future, with AI clearly seen as the key enabler. We're entering an era where solar inverters aren't just power converters anymore. They're intelligent system managers that continuously monitor, analyze, and optimize their own performance. The widespread adoption of AI-powered solutions is set to enhance solar energy's reliability, making sure installations keep producing clean power for, honestly, decades to come. Your inverter is the heart of your solar system, and only intelligent monitoring can ensure that heart keeps beating at peak performance. So, the real question isn't whether to implement advanced inverter monitoring. It's how quickly you can start realizing the benefits of intelligent, predictive solar energy management that maximizes every ray of sunlight and every rupee of your investment. Like, share and subscribe for more solar insights. ClearSpot. Smart device, smarter decisions.